Hi, my name is Sarah Lynn, and I'll be going over problem 6. So this problem says that the ramp is now tilted downwards from problem 5, and the sphere leaves the ramp at 1.5 meters per second as shown below. So that's the initial velocity. And we also know that the bottom of the ramp is 0.9 meters above the floor. To sketch the projectile leaving the ramp, we know that this is a projectile motion question, so the only force acting on this ball right here is gravity. So it's going to go in a down-facing parabola like so. That's part A. Now, for part B, to calculate the range of the sphere, we're going to utilize a kinematics equation. We have every single variable. We have initial velocity, initial position. We even have acceleration. What we don't have is time. So, in order to find time, let's use this kinematics equation. We're going to be solving in the y direction because that's where we have our information from. So right now we're going to solve for time with this equation. So to find time, we want to find this component of velocity, and as you can see, this angle is 15 degrees here, right? So in order to find the components of velocity, specifically, we want the vertical direction right now. But be careful here. It says that it's going down, so we're going to put a negative sign here, because this velocity, down, we're taking the down direction as the negative direction. So it's going to be negative 1.5, which is our initial velocity, and then sine 15 degrees. Punching that into your calculator, you're going to get 0.389 meters per second. We're also going to find the horizontal component. This will not be negative because it's going to the right, and that's the positive direction. That's a theta, apologize. 1.5 cosine 15 degrees. Punching that into your calculator, you're going to get 1.449. Now that we have everything, we can plug everything into this equation right here. So we're going to rewrite this right here. Our initial position is going to be 0.9 meters plus this component that we solved. Now punching that into your graphing calculator, setting this to 0, solving for the quadratic. You could also do it by hand, but that's not necessary if you have Desmos or some other graphing calculator. We're going to get time equals 0.391 seconds. So now that you have time, now you can find range. Now in order to find range, we can use this simple formula right here. V initial in the x direction times t. Now we solve for the horizontal component here of velocity, so we're going to use that times the time that we just solved for as well. And with that, you will get a range of 0.567 meters. And that's it.